according to the law of conservation of mass, the amount of stuff I start with in a reaction has to equal the amount of stuff that I end with in a reaction. So what if I want to react this molecule with this type of molecule and keep track of what happens? How do I do that? How do I tell how much of these I need and how much of these I need so that I can keep track of that and show that what I start with is what I end with? That's what we'll look at today. Here's what you're going to see in this next sequence. We're going to react some of this with some of this. And the way that we're going to do that is we're going to take this molecule all apart and separate it out into all of its atoms. We'll break all these bonds and rearrange them with all these. We'll break these bonds and take these atoms, and we'll join them together to make the products that we're going to make. And once we've made the products that we're going to make, we'll find out how many of these does it take in reacting with these to form these products so that no atoms are left behind. And by doing that, we'll satisfy the law of conservation of matter. One, two, three, four. 1, 2, 3, 4, 5, 6. I've made some carbon dioxide. I've made some water. Now it's time to go back and figure out how many molecules did I end up using to make these so that I can finish my equation. At this point, all of our compounds that we'd made over here have been converted back into the reactants that we started at. So here we have 1, 2, 3, 4, 5, 6, 7 of these O2 molecules. And here we have 1, right? There's 1, there's 2 of these C2H2 molecules. Okay? We have 2 of those, and now we know that it's going to take 2 of those C2H6 molecules and 7 O2 molecules to react completely with each other and form the 4 CO2 and 6 H2Os over here without having any atoms left over. Nothing is left over, nothing's left unreacted, right? And so when we've completed it, that's what we call balancing the equation. And the reason we have to balance the equation is so that we satisfy the law of conservation of matter. It's how we show on an individual level, atom by atom, how many of these will react with how many of those to form these things, having none left over, and every single one of these atoms is accounted for in the products that are made.